Assalamualaikum warahmatullahi wabarakatuh. My name is Nurul Afika binti Hamzah from KSC. So today I will do my task on making a video about explanation on recursion topic in data structure in algorithm. So let's get started. So I will start with the definition of recursion. Okay, the recursive definition is a programming concept that defines itself or self-reference, or in another word we can say that a program that allows you to call a function inside the same function. Okay, next, each recursive function should conduct a small problem size. Okay, we can say that a recursive function process is like a big door, and each time we open the door there is a small one inside the big door, and when we repeat the process until we reach the smallest one, whereas the door is no contain any door, it says it seems like the recursion process. Okay, I give some example of computing recursion process. Okay, for example, we have that we want to compute 3/5. So in a way we can do like 3 times 3 times 3 times 3 until 5 times, and we get the answer. Or in another way we can do like 3 power of 5 is equal to 3 times 3/4, and we can do until we get the smallest power of 0 is the smallest one, and we call recursion. There are two types of recursion solution, which are, the first one is base case, that is easily for solvable, or in another meaning we can say that base case, a method that does not call itself. And the second one is recursive case, which is break down the problem into a smaller problem in the same form. Or in another meaning we can say that recursive case is a method that call itself. There are several types of recursion application, which are the first one is Fibonacci series, graph traversal, tree traversal, quick sort, merge sort, binary search, linear search, and Tower of Hanoi. Okay, this is some of example of recursion, which is this example of Java method of computing 3 power of n. So this example of pseudocode. So from this example we can label that the first condition as a base case and the second condition as a recursive case. Okay, so I will explain how. Okay, for example, we enter the value of n. For example, I enter the value of 0. Okay, for example, so when I enter the value of n is 0, so it will meet the first condition, which if n equal to 0, it will turn 1.0. So if I enter the value of n is 0, and it will return the result of 1.0. So finish. Okay, so other example, if I enter the value of n is equals to 2, okay, we will meet the first condition is if n equal to 0, but 2 is not equal to 0. So the second condition we call the first function, which is 2, and it will return 3 times power of n minus 1, which is 3 power of n minus 1, which is 3, 2 minus 1, 3 power of 1. So this is the answer. Okay, so we go to the four types of recursion method. The first one is tail non-tail recursion, direct and indirect recursion, nested recursion, and excessive recursion. Okay, the first one is tail and non-tail recursion. Tail recursion is characterized by the use of only one recursive call at the very end of method implementation, while the non-tail recursion is characterized by use of more than one recursive call. Okay, so I will show the example of difference between tail and non-tail recursion. Okay, so next we go to direct and indirect recursion. Okay, for direct recursion, I can explain that for example, X wants to make a recursive call with X itself. So it's like a way or a journey from X to X directly. So it calls direct recursion. And for indirect recursion or indirect recursion method, where it is go through by calling other methods. For example, X want to go to X itself, but it go through X to Y to Z and reach the X back. So that's called indirect recursion. Okay, so we go to next type of recursion method, which is nested recursion. Nested recursion, we can define that as a parameter which define the in terms of itself. Yeah, so we can look for the example of nested recursion. Okay, this is an example of nested recursion, which the meaning of a parameter that define in terms of itself. So from this example, we can see that the terms H is repeated or in the same parameter, or you have same parameter. So we can define that the parameter is defined in terms of itself. Or another example, we can look in Ackermann formula. So we go to the last type of recursion method, which is excessive recursion. We can define that excessive recursion method is repeat the computation of some parameters that we can see that it needs a long time of computation to get the result. So we can go to the example of excessive recursion. Okay, next is the example of excessive recursion. So there is an example of pseudocode of excessive recursion. Mostly excessive recursion is used in Fibonacci series. Okay, so the pseudocode that define the first condition is n less than 2 and it will return n, else return fib n minus 2 plus fib n minus 1. Okay, for example, we enter the n value of 6. Okay, and then we meet the first condition, which is n less than 2. 6 is more than 2, so it will go to the second condition. Okay, so when 6 meet the second condition, okay, the first one is 6 minus 2 and we get 4, and other than that is 6 minus 1 equal to 5. Okay, then right now the n value will be 4 and 5. So 4, we enter the value of 4. Okay, 4 is not less than 2, and else it will go to the second condition, which is 4 minus 2 is 2 and 4 minus 1 is 3. Okay, for the 5, okay, we enter and not less than 2. Okay, 5 minus 2 is 3, 5 minus 1 is 4, and we continue, we repeat the process until we get the value that less than 2 and it will return n. So like this. Okay, 2, when we enter the value of n is 2. Okay, 2. Okay, for example, like this, we get the 0. When we enter the 0 value of n, 0 is less than 2, and the result is return n. The answer is 0. And also 1, when we enter the value into the n, 1 is less than 2 and it will return result of 1. from me about explanation on recursion topic. So I've done my task and thank you.